So in this video, we're going to be looking at the runtime context, the LangGraph graph runtime context. Now, sometimes there are some values you don't want to specify in your state. Most likely probably because the values don't change, or they are like configuration values or just static values that you will need to work within your graph, but they're not state values that will most likely be changing from one node hop to another. Things like probably your LLM provider, a file URL, a database connection, even prompts. You want to just store them throughout anytime you run your graph. They're not going to change. You can override them for specific runs, but they mostly don't change, and they are not involved in the actual state activities. But you still want them to be present for the graph to access. Probably things like user ID, stuff like that. You just want to hold them somewhere so that they can be available for your graphs to use. Those are the type of things you keep in your runtime context. They are basically the candidate for configuring your graphs in LangGraph. They're the favored candidates for configuring your graph over runnable config based on what I saw in the new documentation, the 1.0 documentation of LangGraph that is going to be released this October. So these values, you provide them at runtime. They cannot be modified by your node. They can't be modified. They can't be modified. They can only be changed at your invocation. Anytime you invoke your graph, that's the only time that you can override them or set values for them. But your nodes can't change them. Your nodes can't change these values. Also, you can set defaults for them at the beginning of when you're setting up their schema, because you also need to set up a schema for this data bucket. When setting up the schema, you can provide default values. So that you don't have to always provide all the values when you want to invoke. When you want to invoke, you probably only provide values you want to override. And if you have no value you want to override, you don't need to specify them. So let's say you have a graph. Your graph, and let me make this yellow. Okay, or pink. Yeah. Let's say you have your graph. So you have your state already operating in your graph. And let me make this solid. So let's say this is your state. But you want to have some values available in your graph that are not going to change, that the state is not going to change. So that's what you introduce a runtime context for. So you store these values in your runtime context, and your graph can always pick them up anytime it needs to access them. Like I said, things like probably a file URL, some database pointers, a list or an enum list that you just want to use within your operations. You can just keep them in this runtime context. And like I said, you set default values for them. Things like your LLM provider and stuff like that, you can always set default values. For example, let's say you are using OpenAI, so you just set your LLM provider to be OpenAI. You can also set the name of the model you want to use, whether GPT-4o, O1 mini, or stuff like that. You can set that. But at runtime, anytime you want to invoke the graph, you also have the ability to override those defaults. Now, how do you define this? How do you set this up? Let me move this down. Now move everything down. Okay, good. Let's move everything down. Now, you first have to define a schema. Just the same way you do with your state, you have to define a schema for your context, your runtime context. So say class, let's say context schema, but you can give this any name you want. Basically, it's recommended that you use a data class. And that makes sense because you will be setting default values. If you use a typed dict, you can't set default values. So that's why type dicts are mostly used for state, because most of the time in state you don't want to set default values. You just want to have an initial state when you run your graph. But for context schema, you would be setting default values a lot, so it's better you use a data class so that you can go into that data class. Let me put this a little bit. Go into that data class and define values. Let's say user ID, which is a string, and you can set that string to Optimus 001 prime. So you can set that right there in the schema, and if you don't override it when you are invoking your graph, this is just what your graph will continue to use anytime it needs to access this data. So once you have that, once you set your context schema, you then need to pass it to your when you initialize your graph with state graph, you need to pass it to state graph. So you say builder, and you say builder. Let me increase this a little bit. Okay, let's go to large. Okay, good. This large. Okay. So when you say builder, state graph. So obviously you want to pass your state schema first. So let's say graph state. But then you need to pass a context schema. You need to pass this context schema. If you want to use runtime context, you need to pass the context schema, and that's going to be set to your context schema class. Going to be set to your context schema class. Bring that in. Then I can't color this guys individually. Yeah, so that's kind of a bummer. So what did I do? Back to black. Okay, so you pass in context schema and you pass in your context schema class. So you pass it in, so the graph is aware that you want to use context schema. And then once you have this set up, you can then have access to your context schema inside your nodes. So let's say you define a node, say my node. The first argument will be your state, definitely. So that will be your state class. And the next is going to be runtime. It's going to be runtime. And this is going to be of type runtime, which you will get from LangGraph.runtime. We're going to be seeing it in the demo that we'll do after this whiteboard session. But you need to annotate this runtime with your context schema. You need to annotate it with your context schema. So with that, you have your runtime available inside your node. And if you want to access it, let's say we want to access our user ID, you can say something like user ID equals runtime.context. So runtime.context, context.user ID. Because it's a class, you can use the dot notation, runtime.context.user ID. That's how you get the values in your runtime context inside your nodes, and you can use them for anything you want. You can use them for any operation that you need to perform in your node. For example, let's imagine that email example. Let's say in the context, we already have the name of the user, or a dictionary that contains the name of the user is already in the context. So when the input comes in as the body of the email, and we go to the node that drafts the email, it will automatically put the user's email and the user's name in the from field, and also personalize the email with the user's name. And yeah, everything is gotten from the context. All those information are gotten from the context. And when it goes to another node, it can also perform any operation with the user's information. So those are the benefits of using context. It just gives you all these values that you can store in the background, and you can just pick anytime you want. But like I said, you can't change them. You can't change them inside your nodes. You can only change them at runtime. And speaking of runtime, whenever you want to override, let's get another box now. Let me push this down. Let's bring this down. Let's bring this to up here. So whenever you want to invoke your graph, and you need to override any one of your context properties, first you need to make sure that you're passing your state as input. You can't just pass it directly because you need to be able to use another argument. And the argument for passing in context is the context argument. And let's say we want to override the user ID. We simply just pass in another user ID. Let's say for this particular invocation, we want to use another user ID. You can pass in another user ID and say user USR123. Yeah. And that will override the first user ID, which is Optimus Prime, Optimus 001 Prime. It's going to override that for this particular graph invocation. So that's how you can override the defaults that you have defined inside your context schema. So that is runtime context, and the next thing we're going to be doing is going into VS Code to see how this works. So back in VS Code, let us run a simple demo that is going to show us how the runtime context works in LangGraph. To begin, I'm going to create a new file, and I'm just going to call that runtime-context demo.py. Okay, that's good. Now it's going to be a simple, straightforward example. We're simply going to be storing some information in our runtime context. We're going to be invoking without overriding, then we're going to be invoking with overriding. So yeah, that's the old gist. Let's begin. First, let us bring in our data class. Say from data classes, import data class, because that's what we're going to use to create our runtime context. Then we bring in typed dict for our state schema itself. Then we're going to bring in our graphing tools from langgraph.graph. And finally, we're going to bring in runtime. So runtime is from langgraph.runtime. Bring in the runtime class, runtime. Okay, so that was all good. Let's start by creating our state schema. So the typed dict, and we're just going to have an input to be a string, and we will have a result, which will also be a string. So user input and whatever we want the result to be. We are more concerned about our context, runtime context. So yeah, just put something there. Now for our runtime context, as I said, because we want defaults, we're going to use a data class. So the data class, and then we can say class, and we call this my graph context. My graph context. Like I said, you can give it any name you want, call it any class name you want. So just get very descriptive. Now the first thing we want to put here, let's put a property called user agent to track the user agent that is in operation. So user agent is a string. Then we also want the URL to the official LangChain documentation for some reason. By the way, I'm not trying to build any specific thing here. I'm just trying to dump data to just show how runtime context works. So just going to be doing random stuff. So let's say for some reason we want the documentation URL for LangChain. So it's at docs.langchain.com. And for some reason there is a DB connection that we need to maintain because we might want to call our database. So I'm just going to say DB connection as a string and set that to MySQL user :password, and it will be at localhost. So we're running the local DB and the MySQL port 3306 / the name of my database, which is my DB. So yeah, let's say these are the information we want to keep in context: the user agent, documentation URL for LangChain, and a DB connection. So we have this. Now let us define a node that is aware of our context and it accesses our context and just prints a bunch of those stuff out. So let's just do that. Let's say define node with or let's say context access node. Yeah, and like I said, as usual, your node is going to take your state, but then it can also take the runtime. The runtime argument that is set to runtime type and is annotated with your runtime context schema. So we'll get that in place. And inside here, I'm just going to print executing node. And inside here, what we're going to do, we're going to get all those context information. So let's say user agent. Or first, let us get our DB string. So DB string equals runtime dot context dot DB connection. Then we can also get our documentation URL, say docs URL, runtime dot context dot docs URL, and finally we get our user agent. Awesome. Then down here we can simply print 3 of them. So first, let us say current DB string, and we'll just give you the DB database string. Go down and say documentation URL. That'll be docs URL. And lastly, we can say print user agent. And that will be in a user agent, your user agent variable, rather. And just for good measure, let us return something to the state. Just going to return results, and we'll say context. This is an F string. Context accessed, and the DB we are using. Let's say the DB we're using. Context accessed. The DB we're using is let's just print a subset of. Let's put a substring of the DB, because later on I'm going to be switching it from MySQL to Postgres. So this will just tell us when it has switched. So we only need DB string, and we call the split function. Now let us split it by the 2// and get the very first part of that string. After that, we can just say dub. So that when we switch to Postgres, it will just tell us the Postgres part. So yeah, we have this. So this is the node that is going to be accessing our context. And with this in place, we can just quickly build out our graph as a single node graph. So I'm going to say builder equals state graph. Now, like I said, we're going to give state graph our graph state as we always do. Graph state as we always do. But now, because we are using context schema, we also have to make our graph aware that we have a runtime context. So, and that will be done using the context schema argument, and then you give it the schema that was defined using the data class. So we'll give it that schema class, and we can go down here and then say builder.add node. We only have this context access node that we defined, so we just put it here. Then let us add our edges. Builder.add edge. We start and go to our context access node. Then from there, we just end. Yeah. From there, we just end the graph. And finally, we can compile our graph. Graph equals builder.compile. Awesome. So we have a simple one node graph that we're just going to use to test our runtime context. So let us try out some things. First, let's run it without any overriding of the defaults. So I'm going to say initial state. Just say initial state equals is that spelled? Okay. Initial state. So that will be input. And here we can just simply say anything. Let's say start process. Let's call it start process. And we can just feed that. We can just invoke that and say final state equals graph dot invoke initial state. Graph dot invoke initial state. And down here we can print our final state. Print our final state like this. Okay. So, like I said, for this first run, we're not overriding anything. We just want to use the default inside the context runtime or inside the runtime context. So let's save this. From the command line. Now let's run the function Python runtime context demo.py. And let's hope everything works fine. So we actually get an error, and this says non-type object has no attribute DB connection. Now this might cause us to kind of look inside here and feel we do have a DB connection. Like we do have a DB connection here. So why don't we have that? But then I remember that for runtime context, any field that we define in our class that we don't set a default value for, we need to provide it. We need to provide it when we are invoking, because that value cannot stay empty. So here we are simply just passing in the state. So we're not setting the context. We're not giving this user ID a value. So it doesn't have a value. So it needs a value to operate. So let us fix that. Because we want to pass context this time, we need to set input equals initial state, and then we then pass in context. I didn't want to pass it at first because we're not overriding anything, so I felt okay, let's just pass in the state and let's see what happens. But then we have a field inside our context schema that doesn't have a default, so we have to set a default for that. So let me just set that. So user agent. So I want to fix that first. If we still get an error, we're going to figure it out. But for now, user agent, let's call it default platform. Default platform. Let's say that's the name of this platform for some reason. So yeah, let's pull this up. Let me clear the command line. And now let us run this again. And yeah, that turns out that was the issue. Turns out that was the issue. But it's sometimes some issues arise, and it's kind of good that it came up because I forgot to mention that part, that if you don't set a default for a field in your context schema class, it's going to be a required field. That automatically makes it a required field. So you need to define it in your context. So this runs fine. We are able to print out our current DB, our documentation URL, and our user agent. We're not overriding any of the defaults for now. We're just simply setting the user agent, which is a required context value. But let's see if we can override the database connection. So let's say here, we say for this run, I want you to override DB connection. Now, passing in a value for a required value is fine. It is not overriding anything. Passing in a value for a field that has a default value already, you are overriding that default value. So that's what we're doing for DB connection here. So let's say for this, we now decide to go with Postgres, new user at remote host colon 5 what's Postgres 5432, right? Yeah, 5432 / production. So let's say this wants to our production database, and our production database is Postgres, and the name is production. So let's say this, and now let's pull up our command line. Let's clear, and let us run this file once again. Boom. Now the current DB string has changed to Postgres. But now if you look at the input, or rather in the final state, you see our result now says context accessed DB, and the DB is Postgres. Before we had MySQL, now it's giving us Postgres. So you see, we've been able to use runtime context. We've also been able to access it, and you can use it for anything. You can use it for anything. You can use it to call APIs. For example, you might also want to store API endpoints there, so that when you want to call an API, you just pull the URL from the context and use it to call the API that you want to call. And I said I wanted to test something out, which is the fact that in our edges video, we're able to, no, in our nodes video rather, we're able to access runtime context like this. And I believe that's because we're using a typed dictionary. But using a data class, most likely, I don't think we'll be able to access it this way. But let's try. So save that. Run. And yeah, definitely we get an error because this is a class, not a dictionary. This is a class, not a dictionary. So if you use a dictionary like type dict to define your context, you won't be able to set default, which is one thing you have to note. You won't be able to set default. That's why data class is chosen. So just use data class. And if you use data class, it's a class, so you need to use the dot notation to get your fields. So yeah, just wanted to put that out there also.